Hello, and welcome to day 32 of learning ML from chatgpt. And in today's video, we'll be recapping days 16 to 20 of the ML series. So let's get started. So in this program, we made a GAN model, and let's see what our accuracy was first. Oh, okay, we had a lot of output. Okay, let's see. If we just scroll down to the bottom, wow, that's a lot. We had a total only accuracy of 0.46. Okay. Anyway, this was the code that ChatGPT gave us. So here we're using still transformers, I think. Actually, are we? No, we're not. So we're generator model. So we have a dense layer, a leaky ReLU, activation. Well, ReLU is an activation function, and leaky helps introduce non-linearity. Then we have a dense layer again, 748. That is like the image size. So activation equals tan h. This is a range from -1 to 1. Then we're going to reshape the digit in 28 by 28 because 784 is 28 squared. Okay, then we return the model. Then we have a discriminator where we flatten the input layer. We have a dense layer, a leaky ReLU, and another dense layer with the sigmoid activation function. So here we're having a GAN. We're building the GAN model. So we have the generator and discriminator, which is key for the model. And we create a sequential model with a generator and a discriminator. And then we compile it. And finally, we can train it doing. Let's see where it is. Okay, train on batch. There we go. So that's all for day 16. So again, our generative models, grid world. So this was Q tables. So this is unsupervised learning. So Q learning agent. Basically, we have a table or the we have a action and the value for that. Oh, it's the state action pairs. Then we have the Q value, which is like the value that the model predicts we'll get. The higher the value, the better it is. So here we're just making the simple grid world problem, then having a Q learning agent, and then we're just going through each episode. Well, 1,000. So we're doing it 1,000 times, and then we're it's basically rewarding the modern things like that. So then on to day 18, where here, let's see what we mean. A Q model. So this is instead of just using Q table, we're going to use a neural network with our Q values. So we have dense layer, ReLU activation 24, neurons, input shape is this environment observation space shape from the cart pole environment setting. Then we have a final layer of the activation space.n. So this is very useful data as it's got many built-in things. Activation linear. Okay, here are all our hyperparameters and loss functions, and then this is kind of just boilerplate code for training. So then on to day 19. So here we're using autoencoders for the MNIST dataset. So this is when we encoded a dataset and then try to decode this. And if we get any errors in the process, we have we know that this image is erroneous. So therefore, it is anomalous in our results. So, for example, we are doing this on the MNIST dataset. But because it's such a widely used dataset, it didn't have many errors, or it didn't have any errors, in fact. So then on to day 20, where we use k-means clustering, which is where we see here we're just clustering our data together. So we have k-means, then we have hierarchical clustering, which you can see like this, and dimensionality reduction, which looks like this. There were some cool analogies as well to go with it. It's like clouds, something to do with that. Yeah, so that's all for today's lesson. So thank you for watching, and I'll see you in the next video. Goodbye. Yeah. I'll just quickly recap these. So k-means, hierarchical, and PCA, principal component analysis. So yeah, thank you for watching, and I'll see you in the next video. Goodbye.